A 50.91 gram sample of chromium is heated in the presence of excess oxide to form a metal oxide with a mass of 74.4 grams. What is the empirical formula? So the first step we're going to take in solving this equation is we're going to find how many grams of oxygen there is. Since we already know the amount of chromium and the total amount of metal oxide, it's going to be quite simple. We're just going to subtract the mass of the metal oxide from the how much chromium there was. So 50.91 grams of chromium. This is going to give us 23.49 grams of oxygen. Now the second step is to determine how many moles of chromium we have and how many moles of oxygen there is. This is going to be simple. We're just going to take the 50.91 grams of chromium and we're going to divide it by its molar mass. So the molar mass of chromium is going to be 1 mole chromium over 52 grams. Now this right here is from right to left, we're going to multiply, and from top to bottom, we're going to divide. So 50.91 times 1 is going to be 50.91, and then divided by 52 is going to give us 0.9790. To determine the units, we're just going to see whatever we can cross out. So these two cross out, and this leaves us with 0.979 moles of chromium. Now we're going to do the same thing for oxygen. We have 23.49 grams of oxygen divided by the molar mass, which is 16 grams of oxygen for 1 mole oxygen. This is going to give us, so 23.49 divided by 16 is going to give us 1.468. And then to determine the units again, cross these two out, and we're left with moles of oxygen. Okay, so we're still not done yet. We still have to determine what the empirical formula is. So in order to do that, we're going to have to see which one has a lower mole ratio. So since 0.979 is less than 1.468, that is going to be our denominator. So